Okay, let's take a look now at some strategies where we have a bad leaving group and we want to make it into a good leaving group. Just talk more about leaving groups in general. So leaving groups are nice compared to nucleophiles because, they're easy to predict whether they're going to be good or bad. If it's going to form a weak base, it's going to be a good leaving group. Otherwise, it's not a good leaving group. And that's really nice. In organic chemistry, we don't have a whole lot of things like that where it's just reasonably straightforward. But yeah, so if we look at something like, if we're trying to do a nucleophilic substitution, and we have bromide, and we have OH in there, this reaction isn't going to go because the leaving group is hydroxide, and that's no good. So what we can do is we can add a little bit of acid in. So you could start out and just use HBr, or you could add in a drop of H2SO4. Let's just, I'm not sure how to annotate that. Let's just do this. Let's just say instead of starting with HBr, instead of starting with Br minus, I start with H2SO4. And now this reaction will magically go, and the reason is that the leaving group gets converted into water. So if you want to see the mechanism for that, you can go back to one of the previous videos where we kind of show that. I think it's the one right before this. So we'll get this, but we'll get water as a leaving group. So there's an extra protonation, deprotonation step that happens there. Okay. So when does this strategy work and when does it not work? So generally, it works fine as long as your nucleophile is not a strong base. So if you were to say, what if I wanted to do, let's say I had the same substrate, okay, and I'm still, all of these, this is all, I'll say these are SN2 because we haven't really been through that yet. These are all going to go SN2. So at this point, I think it's, even though you don't know how to identify whether it's going to be SN2 or SN1, it's a good idea just to straight up have those mechanisms at least memorized. Okay, so if you're kind of figuring out how you want to learn this, I think this stuff will probably make a lot more sense if you at least have the mechanisms memorized. At the very least, just have a crib sheet next to the lecture so you can kind of follow what's going on. But yeah, let's say you're trying to do another SN2 reaction, but now I'm going to try and do it with, let me change this a little bit. Let's say that I have methoxide. It's okay, so still a bad leaving group. But now I want to try and use NH2 minus. Right? So I'm trying to set this up to where it works. Let's say I want to use OH minus. That works. Okay. So I want to use OH minus, and I want to try and do an SN2 reaction here to displace that. Yeah, maybe this reaction will work a little bit, but probably not. It's generally you just don't see this happening. You're not going to see a bad leaving group. You're not going to see a strong base form. It's atypical at least. Okay, so this probably isn't going to go. So what you might want to do, and say, oh, I know what I'll do. I'll add some acid because that's worked previously. What if I just put in a drop of H2SO4? Because then I'll form some hydronium, right? And H3O plus. You might be thinking this, and awesome, now I've got my leaving group good. Now I've made my leaving group good. Like this, and I can come in now with my OH minus. Kick this off. You can tell by the way I'm talking that this is, or hopefully you can tell that this is not how this goes. This won't happen. What's the issue here, right? If I add in sulfuric acid to try and get this reaction going, and my nucleophile is a strong base, is it possible for me to have both a strong acid and a strong base present simultaneously? Hopefully, you're saying no. So this is a big point of confusion for students throughout organic chemistry, especially in the second course too. It's not possible, and we'll see this again and again and again in this course and in the second course, not possible to have a strong acid and a strong base. Okay, I should probably actually write out acid. Strong acid and a strong base present at the same time. So you may have enough lab experience for this to just make sense to you. If you don't, it's kind of like they're opposite things. You can't have both simultaneously. Just like it's kind of like you can't be simultaneously hot and cold, Or if you can't, if you're trying to make like a drink and you're like, I'm going to make a drink that is both hot and cold simultaneously, it just doesn't make sense, right? Because those two things work opposite to each other. And so it's the same thing is true for strong acids and strong bases. You just can't have them present simultaneously. And it's for that same reason that you can't have something that is both hot and cold simultaneously, right? So these things are opposite of one another, and it's just not how things work out in our world. So this doesn't work because what you will end up having, right, you won't have any OH minus left. All of your OH minus is going to react with your acid, the sulfuric acid, and then you're not going to have a good nucleophile anymore. What you're going to have instead is a lot of water and some H3O plus. And water is not a good enough nucleophile to do this reaction. Okay? So this does not work. And similarly, if you're trying to use like NH2 minus, and you're trying to displace some bad leaving group, okay. Again, for the same reason, if I try and put an acid, the acid is not going to react with, well, I mean, depending on how much you put in there even, it's not going to react with the leaving group. It's going to react with the strongest base that's in solution. You're going to get this reaction. Okay, so then you're going to convert your good nucleophile into a moderate nucleophile, and your leaving group is still going to be a shitty leaving group, and you're not going to get any reaction to happen. That's probably a better example. And a clearer explanation, to be honest. So hopefully some of that sticks. So yeah, if you have a strong base, you can't add acid in to make the leaving group good. That's the basic thing. So what nucleophiles are not strong bases, that pretty much tells you which ones you can use this acid strategy for. So if you think about your nucleophile list, obviously there's a lot of gray area in terms of what you can get away with here. But generally speaking, things like this, you can get away with adding some sulfuric acid. Maybe like cyanide, you could get away with adding some acid as well. But a lot of these other ones, you're just not going to be able to get away with that at all. Okay? Even for cyanide, you probably wouldn't be able to add a strong acid, but you can at least add some acid to solution. So I guess what I'm saying is, so I can simplify this, because I feel like I'm just kind of rambling here. Generally, this strategy of adding in strong acid only works for these halogens. Let's just simplify it to that for now. We can, if we get to the cyanide and stuff, which I think comes in, we'll look at that in one of the later chapters. We can talk about what the best conditions are for it. Okay, but these are the only ones that you can use acid in. So what do you do then if you have a bad leaving group and you want to make it a good leaving group? Well, sometimes it's just not possible. So if I'm working with, let's say, this, and I'm trying to do some sort of nucleophilic displacement like in the previous one like this, that just doesn't work, and there's nothing I can do about it. I can't add any acid to this. so I'm just kind of done. But if my substrate was, let's say, this, okay, I can actually do something here. So before I introduce in my nucleophile, what I can do is I can react this with tosyl chloride. So remember this weird thing that we kind of looked at a while back? The tosyl group, this is where that comes from. So I can take tosyl chloride. I'm not going to take you through the mechanism. You'll learn that in the second course. But what it does is it takes that bad leaving group and converts it into a good leaving group. Okay. And now, so this would be like step one. You'd have to do these in two separate steps. And then in step two, I take my substrate that I've changed with the tosyl group. And now I can do this reaction. Okay. So what are the takeaways from this lesson? Our two strategies are, one, add acid. But this has limitations, right? Limited, for the most part, to halogens. But I'm going to put in parentheses because I'm sure there are other ones where you could imagine this working. Weak bases. So basically, you just need something where the nucleophile is not so basic that it reacts with the acid. That's the issue, right? If most nucleophiles, if a nucleophile is a strong base and you add in some acid, well, naturally you're just going to get an acid-base reaction. So in the more unusual cases of nucleophiles, where they're nucleophilic but they're not strong bases, like the halogens, bromide and iodide, you can get away with just adding an acid. Two is you can use tosyl chloride, which looks like this. Oops. What I wanted to do, which looks like this. And so we abbreviate this piece here as TS. And so, on the MCAT or on one of the exam questions or something, you might see it written as TS, or you might see it written out as the full thing. And either one of those is fine. And there's other different types of reagents that look kind of like tosyl, that have maybe like a, like you could put a methyl group or something right here. Yes, okay, that's a different thing. That's paratosyl chloride, but that still works, right? So you use your brain to kind of extrapolate out on different things that work, that could potentially work. In our class, we'll generally just stick to the tosyl group, but on a standardized test or something, I don't know what the hell they'll do. So I guess that's the other piece we have to worry about for you guys, right? Is like, one, we want to make sure you do well in the class. I can obviously help you with that because I'm in charge of your grades. But two, we also want to make sure that you're prepared for the second course. That's something that I really trying to take a lot of concern for, especially because things are rough right now. But also three is ultimately this stuff comes back to haunt you a little bit on the MCAT. I know they've cut down what's on there. And then maybe not four, maybe four for you guys, but not for me, is like, I want you to actually learn something and to carry it along with you and hopefully have that be useful for you in life in some way. So anyway, so we've got these two strategies. One is to add acid. So these are for converting bad leaving groups. To convert bad leaving groups to good. And then, in some cases you have a bad leaving group, and it's just a bad leaving group, and the molecule is not super reactive, and there's nothing you can do about it, right? And that's just something that happens. So yeah, those are your two strategies. So